Okay, read it from your picture. Okay, so empirical formula is a really crazy word that just means like reduced down fraction. So I'll show you, like, for example, if I had something like H over here, if I did, let's say there was something called like C2O6. All right, so let's think of the fraction 2 over 6. Is 2 over 6 reduced? Oh, so, oh, hold on. Okay. Okay, 2 over 6 is not reduced because they can both be divided by 2. So it's not like you could chop, so basically you could chop it down more. So if I divide top and bottom by 2, what do I get? 1 over 3. Okay. Okay, cool. 1 over 3. So here, do you see, like, I could go like this and be like 1, 3. So the empirical formula for C2O6 is C1O3. But then you don't actually have to write the 1 there, but you can. Does that make sense? So what's the empirical formula for C50? I don't know. I'll just make something up. HG 100. Perfect. C1, and I don't actually think this is a real thing, and I probably put it together completely wrong. That's how you do it. Okay? So what's empirical formula? It's like reducing like the little subscripts on the formula. And the first part of empirical formula problem is actually super, super easy. You get your percentages. You see how you have your, in black, you have 32.38% sodium. I'll write as Na. And you have 22.65% sulfur, right, as S. And you have 44.99% oxygen, right, as O. Okay? It's my favorite part about empirical formula problems. Magic. 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 You turn all of these into grams. So now it's 32.38 grams. 22.65 grams. 44.99 grams. What allows you to do that? Magic. See? Poof. You with me? Okay. So that's like almost puts you like a big chunk way through the problem, by the way. So you have all these numbers. So now you get your 32.38 grams of O. You should write what they are. O, that's not O. Na, S, and O. I remember learning this for the first time and being like, wait, what? You can just do that? No explanation. Okay, 1 times. All right, so our goal is to take this to moles, which is also part of your test. So you want to go grams to moles. You want to go grams to moles for all 3 of those. All right, so what's going to go down here? Grams. All right, so you're going to go grams to moles. You're going to put grams here. What do I put? That's exactly what you put. Ashley said molar mass, and I just said that's exactly what you put. So you go on your periodic table, and if you want to go, watch this. If you want to go grams to moles, you go grams in. So you go grams to moles. You could also go moles to grams, whatever. And it's always going to be 1 mole. Always. 1, 1. But this grams number is always going to be like your mass from the periodic table. That's always mass from periodic table, but that's always going to be 1 mole. Right? So what am I going to put for my grams right there? Well, it's always going to be the mass from periodic table. Oxygen. So look, 16 grams. Now let's see if you're paying attention. What goes up here? How many? 1. See, 1 mole? Always 1 mole. If you're using periodic table, it's molar mass and 1 mole. It won't ever be like 5 moles. If you're getting 5 moles, it's because you figured that out in some sort of calculation. Okay. All right. Why did I write 5 moles? So 1 mole. Cool. So what do you get when you do that? Okay. Okay. 2.03, you said? So what do I write next to that? Moles of what? Moles of what? Moles oxygen. All right. We're going to do the same thing for the other ones. You with me? Okay. So we got 2.03 moles of oxygen. I don't like that color. So how do I set the next one? For each one. Picture yourself day before the test trying to figure this out. Like put like 10 o'clock at night, getting it wrong. It's going to be on the test for sure. Now it's 10:15. Let's go. What do you mean? Oh yeah, I wasn't supposed to do that. That's supposed to be NA. Oh man. All right, yeah. This. No. Okay. No. Okay, hold on. So, okay, hold on. That becomes NA. This becomes NA, and then what number goes down below? You don't know? What goes here? Wait, 1 right here? Right here. Okay, so 22.99. All right. So punch that out. Tell me what you get. I know you want to go like this. Do you want this wrong on the test? Like, what's important? No, this is an incomplete problem. The problem is incomplete. Help you figure yourself out. And then what you're going to do is you should memorize the answer and move on. When you're studying for it, that's not going to help on a new problem. All right, so we have 1.4 moles of Na. All right, that's Na. So how do we do? Now we got to go grams to mole for S. So what do we start with? .06 grams of S, and that's 1 mole of S, and then what do we get? Okay. Okay, 0.706. 0.706 what? Moles. That's what's right here. Moles of S. All right, next one. I'm hearing sighs and sounds of frustration from you. But I don't understand. I don't understand. I don't understand that. Why? To me, that's like getting a cast on at the doctor, and you're like, hurry up! I gotta go somewhere. 44.9, 44.99%. So, sorry, grams over 1. What was that number again? Oh, is that your final answer, you're saying? All right, what number did you put down here? All right, 16 grams of oxygen and 1 mole of oxygen. And then you're saying 44.99 divided by 16? 44.99 divided by 16. 2.8. Okay, one more step, then we're done. Well, actually, we gotta talk about extra credit, because that's due like next week. Hold on. You should do it? Moles of. Yeah, I understand, but don't you want to get like your maximum points possible? Do you want to be in the class? What? Yeah, I understand, but there's different levels of work you can do. You can do C work, B work, or A work, right? If you have a 70, I don't know what your grade is in the class, like a 71% in the class, and you do C work, your grade does not go up at all. Your grade only goes up. Your grade goes up with 100%. So hold on. So look, this problem right here, you have to write down the elements in the order they gave them to you. So read them off to me. No, like first goes sodium, second goes sulfur, third goes oxygen. So you go sodium, and then you go sulfur, and then you go oxygen. Okay. Then down here, you're gonna put in your subscripts. Hold on a sec. All right. Down here, you're going to put in your subscripts. There, there, and there. So what is our moles of Na that we figured out? And what is our moles of sulfur that we figured out? Or, hold on. 0.706. And what are the moles of oxygen? Okay. Does that look like a formula to you? It does? So like, you know how like water is like H2O? Could it be like H.70.3 or something like that? You can't have decimals in your subscripts. All right? So what you do is you divide by the lowest number. You divide all of them by the lowest number. Which one of these is the smallest number? What's that? Point 0.706. So you divide it, this one by 0.706, this one by 0.706, and this one by 0.706. Now I'm going to put them back down again. You're going to have Na, you're going to have S, you're going to have O. But when you divide at least one of, Okay, watch. All right, but what happens to this one right here when you divide? What do you get? What happens to this one? We'll put in a calculator. 0.706 divided by 0.706. 1. Now put this on the calculator. 1.4 divided by 0.706. Great. And then this one over here, 2.8 divided by 0.706. .9. Okay, cool. So I'm going to rewrite everything again. Na, S, and O. All right, 1.9 rounds to what? Okay, 2. That S is still 1. And 3.9 rounds to what? 4. So what is the empirical formula? It's Na2 S. Do you need the subscript on the S? No? O4. Let me check that one. Yep. So it's Na2SO4. That was not easy, by the way. The first part was easy. The magic part. Hold on a second.